Imagine a hidden temple in the mountains. Monks are guarding a sacred puzzle made of pure gold. 64 golden discs stand in a perfect tower, largest at the bottom, smallest at the top, all stacked on one diamond needle. Their lifelong task is to move this entire tower to another needle. They must obey 3 strict rules. Rule 1, move only one disc at a time. Rule 2, never put a larger disc on top of a smaller one. Rule 3, you can use the third needle to help as temporary storage. Legend says that when the monks finally complete this task with all 64 discs, the world will come to an end. But how many moves would it really take? Let's begin with the smallest cases. With one single disc, it's very simple. Just one move, slide the disc to the target needle. Now 2 discs. To move the large one, you first move the small disc to the spare needle, then move the large disc to the target. Finally, move the small disc on top of it. 3 moves in total. 3 discs need 7 moves. 4 discs need 15 moves. 5 discs need 31 moves. You can see the pattern clearly. Every time we add one more disc, the number of moves doubles and then adds one extra move. This pattern holds the key to the solution. To move a tower of n discs from needle A to needle C, using needle B as helper, you only need 3 main steps. Step 1, move the top n-1 discs from A to B. Use C as the helper. Step 2, move the single largest disc from A directly to C. Step 3, move those n-1 discs from B to C. Use A as the helper now. Notice something important. The first step and the third step are exactly the same problem, but one size smaller. We have turned one large problem into 2 smaller versions of the same problem, plus one easy single move. And those smaller problems follow the exact same rules. So we repeat the same method again and again until we reach a tower that has only 1 disc. When there is only 1 disc left, recursion stops. We simply move that 1 disc to its destination. This recursive thinking creates a very clean and short computer program. The function works like this. If the number of discs is 1, print move disc from source to target. Otherwise, first recursively move n-1 discs to the helper needle. Then move the largest disc to the target needle. Finally, recursively move the n-1 discs from the helper to the target. When you run this for 3 discs, you see exactly 7 perfect moves appear. Each move legal, each move necessary, as the recursion naturally breaks everything down to the smallest piece. This elegant solution has one big drawback. The exact minimum number of moves is 2 raised to the power of n-1. For 3 discs, 7 moves. For 10 discs, 1,023 moves. For the legendary 64 discs, more than 18 quintillion moves. If the monks could move 1 disc every second without stopping, it would still take hundreds of times longer than the current age of our universe. The legend, therefore, contains a deep truth. The Tower of Hanoi is not just an ancient puzzle. It is one of the most beautiful and clearest examples of recursion in all of computer science. It shows us how we can solve huge problems by believing that much smaller versions of the same problem will handle most of the work for us. So the next time you face a very hard problem, try asking yourself this question. Can I solve most of this by giving the same problem, but smaller, to itself? That one simple question can open the door to many powerful and graceful solutions. Thank you for watching.